My name is Londia McCafferty. I am the Chief Judge of the Federal Court in New Hampshire. I'm honored to share this screen today with judges from across New England. First, Chief Justice of the New Hampshire Superior Court, Tina Netto. Chief Superior Judge in Vermont, Brian Gearson. District Judge Michael Shea from the Federal Court in Connecticut. Chief Judge John Levy from the Federal Court in Maine. And last but not least, Jack McConnell from the Federal Court in Rhode Island. We are here today with our infectious disease expert, Dr. Dr. Bromage, who teaches science at the University of Massachusetts at Dartmouth. I speak for all of the judges in saying that we strongly encourage our staff to get the vaccine because we care about your well-being and your safety and the safety of everyone involved with our courts. Over the past months, we've received questions from our staff about the vaccine. We decided to get you answers. There is no better person to answer your questions than Dr. Bromage. I will start. Dr. Bromage, some on our staff have asked why they should get vaccinated, including those who are younger and have no underlying conditions. What are the benefits?
So first, thank you for inviting me along. It's great to be able to do this for everybody in the court system in New England. So when we look at the vaccine, so I need to show my bias straight away. I'm wearing my bracelet that sort of says I got my vaccine. And I am one of those people that you're actually talking about. I am under 50. I have no comorbidities. And, you know, it's why, if the risk of severe disease is very low in my age group, should I consider getting this? And it's because of the chains of transmission. We know, and we're seeing it over and over again, that it goes through people under the age of 50, you know, particularly between 15 and 40 years old. And it just smolders through, and occasionally people get really quite sick at that age. But then those younger people connect up with people that are more vulnerable. And the thing is, you don't know who is more vulnerable. For example, you can't see people with type 2 diabetes. You can't see people with high blood pressure. And if it gets to those people through you, you are that connecting link. So we all have a piece in this, game, in this sort of puzzle to sort things out, that it's not just protect the old or vaccinate the old. We need to be that fire break between people that are susceptible. We need to stop it from going from one group to the other that have more adverse outcomes. So wherever we can, we really need to be getting that vaccine, and it just breaks chains of transmission, which means that this pandemic will go to its natural end.
Excellent. Great. Thank you for that. So my question is, when we look at the vaccine, we've seen some reports in the media about serious health problems that result from taking it. What can you tell us about the potential short-term and long-term health risks that might be associated with taking the vaccine?
Yeah, so this is one of the really frustrating parts about watching science happen in real time, because this is the first time a lot of us have seen the actual natural course of progression of science and the way that it works, and it being reported in the media every day, every hour of every day. So with any medical treatment, and it doesn't matter if it's aspirin or a vaccine, there are side effects and adverse reactions. They go with it because everybody is unique on a genetic level. So we know with vaccines, and this one is no different, that there will be side effects. So general side effects for me, it was like someone punched me in the shoulder and I had a hard time lifting my arm for 24 hours. Other people, it can be fever and chills for 6 or 8 hours. And a lot of people, a lot of my friends in the medical field that have had it was just none. There was just no side effects at all. But we cannot deny or gloss over the fact that there are some serious ones. And that's what the media really likes to grab hold of because it gets your attention. So we know that with the Moderna and the Pfizer vaccine, we're looking at about 1 in 100,000 people having an anaphylactic reaction. And that is the most severe reaction, that side effect or adverse reaction that we've seen with this vaccine. So we have anaphylaxis, sort of similar to what you'd get if you're allergic to shellfish or peanuts. None of those have resulted in death. There has been literally no mortality associated with vaccination at all. And the most severe that we've seen today in regards to reactions has been that anaphylaxis. And we're looking at about 40 cases out of, I think we're up to 50 million doses of vaccines into arms at this stage. So the real risk at this is roughly, and it's interesting, science still needs to sort this out. Most of the anaphylaxis is in females, like over 90%. And most of those people are under the age of 40. And in those particular cases, it's 1 in 100,000. So when we look at risk, and this is the thing that we need to be doing with the vaccine, when we look at risk, if you're over the age of 75 and you get infected, you've got a 1 in 8 chance of dying. We know that with vaccination, the risk of severe adverse reactions is more than 1 in 100,000. So the math just makes sense that vaccination is important. Same with over 65, people over 65, it's closer to 1 in 80. Over 55, it's closer to 1 in 200 that will die from infection. And that's not including all the hospitalization and the long-term side effects. So vaccination is clearly a benefit to people to get, even with knowing that there can be the rare side effect from it. So we need to acknowledge that there are risks with it, but understand that those risks are so much lower than what they are in regards to infection. And you may not have worked out, part of the reason why we're not vaccinating kids under 16 at the moment is because it wasn't trialed in them, and we need to be even more careful with the adverse reactions with children, not because they're a special group. It's because if we're looking at 1 in 100,000 kids having a severe outcome from infection, but 1 in 100,000 kids having an adverse reaction to the vaccine, it doesn't make sense to vaccinate. So what we need to do is come up with a different vaccine or a vaccination strategy for children that provides the protection without the risk that comes with the small risk that comes with vaccination. And that's what we're working on for the next 3 or 4 months. So there are risks with vaccines, but they're so low, you'll only ever hear about them in the media when it goes wrong. You don't hear about the 59 million people and such that have had the vaccines and no impact at all because it doesn't make the news. So we need to focus on the reality, the very low risk from vaccination and bad things happening with that versus what can potentially happen with infection. And we know what can happen there.
Doctor, so you focused on the severe side effects, but let's go back to the non-severe common side effects of the vaccines. Could you talk about those for a moment?
Yeah, so one of the interesting things of the side effects with this, and so just the general ones that we expect. So sore arm is the one that most people should expect. And the way that you need to think about this is you're getting the vaccine in your arm, and the vaccine incorporates itself into your cells to make the protein. So these vaccines are the blueprint to make the vaccine itself. And so it gets incorporated into your muscle cells, and those muscle cells start creating the spike protein of the virus. Well, your immune system sees that and goes, we don't want it. And so they start attacking those muscle cells, and that's why the arm gets sore. So side effects that we get, the ones that we expect, are showing that your immune system is actually working and responding to the vaccine. So we could end up with fever and chills. And again, that is a side effect of vaccination, but it's a side effect that your immune system is working. When you have fever, your body is naturally raising its temperature to try to make the environment, your body environment, suboptimum for the bacteria or for the virus. Chills, it's the same type of thing. So the side effects that we get, the mild ones that we get, are really just your immune system showing that it's working and you're feeling that it's working. There is no doubt with the second vaccine that it's a bit more than a punch in the arm for some people. I've had 2 friends that are 50s, 60s, 70s that have, well, more than 2, that have had their vaccines lately, and they were not in a comfortable spot to work and focus for that day. It was about 4 to 6 hours of, oh, I'm hot, oh, I'm cold, oh, I'm hot. So fever and chills going off, a little bit of fatigue, but then the next day they're perfectly fine. So that, again, is part of your immune system working. Fatigue, your energy in your body is being redirected towards your immune system so that your immune system can expand and respond to the perceived threat, which is the vaccination. That's all a part of what's actually going on. So there are side effects. They are minor. You might be out of action for 24 hours just because you're not feeling well, but that is about as big as it goes. And if you want to check yourself, so there's a thing called VAERS, Vaccine Adverse Events Reporting System. You can actually go online and see all the reported symptoms that come from a secondary, vaccination. They're reported by both doctors, but also individuals that go in there. So you can actually see for yourself and verify that there are not a lot of reactions. So we expect a little bit of a sore arm. We expect fatigue, maybe fever and chills for 24 hours. And that's about as bad as it gets in regards to what the vast majority of people would expect.
Thank you, Dr. Bromage. And I want to thank you for all the work that you've done during this pandemic and sharing your knowledge with us and with our courts. There's no question that the speed for which the vaccine has been developed has been considered a great scientific achievement. But some staff members have reservations about the safety of the vaccine due to that rapid development. Can you explain how the vaccine was developed so quickly and whether its rapid development presents any safety concerns? Thank you.
Yeah, so there's definitely rapid development as in this exact vaccine against this target. And if you would have asked me in October, would I be willing to vaccinate my mother or my grandparents? The answer would have been no, not until I see the data. So the data has really been able to convince me that it is both safe and effective. But it would be wrong to say that this vaccine or how we got to a vaccine here is rushed. So we knew how to target the weakness of this virus from the work that started in 2003 with the original SARS outbreak. We knew with SARS that we needed to target the spike protein on the virus. I know it may not be appropriate for courts, but when you're trying to defend yourself against zombies, we know you have to target the head. And you work that out about halfway through the movie that you need to target the brain of the zombie to kill it. So we already had that information from 2003 that the brain of the zombie, the brain of the virus was this spike protein. Now that was confirmed again with MERS, so the Middle Eastern Respiratory Syndrome. So when that flared up in 2009 through actually still to today, we knew again that antibodies and T-cell responses against the spike protein were what we needed to neutralize this so it wasn't a threat. So we knew exactly where we needed to target even before this virus came out. So again, so that's 17, 18 years of research that led up to what is the target of this particular virus we need to go for. Now, mRNA vaccines are new to humans, but they've been around for a very long time in animals and animal models and veterinary models. We've been using them for a long time. And if we want to go specifically at Moderna and look at that, they received their first funding for an mRNA vaccine in 2012. So they had been on mRNA vaccines for 8 years before we even got to this particular virus. They had over $500 million in research and development and funding from the Department of Defense, DARPA, the Bill and Melinda Gates Foundation, NIH, huge amounts of money to work out how to deliver this blueprint to a cell to create a new protein. And so that, again, not rushed, huge amounts of money, incredible amounts of time and effort and research have gone into this. Studies were well and truly underway, 5 years underway to do mRNA vaccines for influenza. And we probably will see those vaccines coming out in the next 12 to 24 months. So mRNA vaccines that will protect you not against one strain, but many strains over a number of years. And again, that's what they had been working on. So when you took, I knew the brain of the virus that I needed to target, and I had the delivery system, all they needed to do was combine those two things together. And so literally, when we had the sequence of this virus, and specifically of the spike protein on January, I think it was 16th of last year, If you look at the interview that was had with Dr. Kizzy and President Biden, she's like, yep, as soon as I had that, I worked over the weekend and made the vaccine. So we had the vaccine for this at the end of January. And then the time between then and now was all safety. We knew the safety of mRNA delivery. We knew it needed to target. So then it was, let's roll it through the process of making sure that it's safe. 40 people first, they test it with 40, no adverse reactions there. So they moved it up to 200, 300 people. That's the phase 2. And then they moved it to the third phase, which was 30,000 people. Now, why could it move through that particular process fast? Because normally that does take 3, 4, 5 years to go through. Well, it could move through that fast because the United States was absolutely terrible at controlling the virus. What we need to do when we're doing these vaccines is make sure they're safe. And the vast majority, 99.99% of all adverse reactions happen in the first 24 hours, and certainly virtually all of them happen in the first 6 weeks. So we know that anything that's going to be long-term would have raised its head in the first 6 weeks after vaccination. So we got that out of the way that it was safe. Then we needed to work out that it was effective. So like with HPV, for example, when we're developing that vaccine, it took 7 years to get enough data from somebody being infected with the virus going on to developing the first stages of cancer so that we actually knew that this vaccine had a significant protective effect on that population. We were burning in the United States with infection. We had so much of it that we didn't have to wait 7 years. We only needed, it ended up being about 45 days to get enough events to say, is this protecting people better than just your own immune system without training? And the answer is clearly yes. The only piece that we are missing right now that we would normally have with a vaccine is durability. We have no idea how long this vaccine will last. It may be 6 months, it may be 6 years. So normally we get an idea of durability to know how long we can go between booster shots. So like tetanus every 10 years, we know the durability. We don't know it with that one. And that's why it was done through an EAU rather than a traditional approval process, is because we don't have durability measurements there. So the safety and the effectiveness is just buttoned up and it's beautiful. We don't have an idea about durability. So we're there and it's a great vaccine. And it's definitely, again, I put my hand up the second that I was offered it to go and get it because I know what it does for myself, my household, and my community.
Thank you, Doctor. Doctor, we've been hearing a lot about variants, the UK variant, the South African variant, the Brazilian variant. If we get the vaccine, are we protected from these variants?
Yeah, so they are very much on my radar at the moment, and that is the big unknown that we have for the next 2 months in regards to what will these variants do. For example, 15% of all cases in Florida are with B117, the variant that was originally identified in the United Kingdom. So it's certainly on my radar and everybody else's radar that's looking at this. So what do these vaccines do? So we are very fortunate, I will say lucky in a way, that the Moderna and the Pfizer vaccines elicit such a strong response and such a robust response that even though they're not quite as effective, especially against the 2 variants that originated in the Southern Hemisphere, even though they're not quite as robust against those, the level of immunity that's actually being generated is so high that even if it's only working at half the rate, it's still providing really strong protection. This is not the case with some of the other vaccines that are out there. And this is why I say we got lucky. The first 2 that came out have generated really robust immune responses against the United States variant, the original variant from the UK, from Europe, and now these 3 other variants of concern. So I've been following this closely. It looks really good in regards to protection against them. Not as strong, but we just need to have it strong enough that we don't go to severe or to death. So we might end up finding that a variant pops up in South America, for example, and the amount of immunity that we have is sufficient to turn it around and provide us protection, but we may end up with a day of fever and chills like you do with a normal cold or something like that. So I am confident based on the data that's being released so far and the variants that we know with the Moderna and the Pfizer vaccines, they do a very effective job at stopping all serious outcomes of infection from the variants that we currently know.
Dr. Bromage, thanks a lot. We know that you and all credible public health experts, as do all the judges on this Zoom, strongly urge everyone to get the vaccine for their own safety, the safety of their family, and the community. Are there any people that should not, any adults that should not get the vaccine now? And then the second part of that question is, what effect does the vaccine have on women who are pregnant or on the issue of fertility?
Yeah, so at the start of this pandemic, so I'm going to answer the pregnancy one first because that's come up a lot. At the start of the pandemic, and especially the start of the vaccine trials, there was not a lot known, and we knew that with pregnancy, there was a higher chance of people ending up in hospital if they were pregnant and infected. So they have been regarded, and we can see in the CDC guidance that pregnancy is regarded as a high risk group for infection because they do end up with hospitalization at a higher rate. So now people that, and then the next part that went on was people were excluded, people that were pregnant were excluded from the vaccine trials because they just didn't want to have a confounding factor there. But with 60,000 people that were involved in the trial and 30,000 of those being female, there was pregnancies that happened during the trial that then were included in the data. And so what we saw from the pregnancies that arose during the trials of these vaccines, that there is no contraindication with being pregnant and getting vaccinated. There's no higher risk at all with people there. So being pregnant should actually not be a reason not to get vaccinated. And because we know being pregnant and getting infected is a higher chance of hospitalization and severe disease, it makes much more sense to get vaccinated when you're pregnant. And remember that there are a lot of infections that we have seen from doctors' offices, from waiting rooms, from hospitals. You can't have your pregnancy in a bubble. You have to have a lot of wellness checks, which is by nature going to take you out and interact you with more people. So vaccination and pregnancy seems to be a very good way, sorry, cat just jumped up, a very good way to actually go. So, sorry, can you repeat the other part of your question?
Sure. There was also the question, do we know whether it has an effect on fertility? But more importantly and globally, are there any groups of adults who should not get the vaccine?
Yeah, so my only cautions that I would put up at the moment is if you are a person that has had a lot of allergic reactions, so you're allergic to shellfish and peanuts and pollen, we need to take a little bit more care when you're being vaccinated. If I fell into that category, that if I was essentially allergic to life, I wouldn't be going to a CVS, for example, to get my vaccine. I would be doing it at a clinic where there was licensed medical personnel, say a hospital, say one of the mass vaccination sites, they have doctors on site. Just in case you are that 1 in 100,000 that does have an anaphylactic reaction, you want great medical care right there to give you epinephrine to pull you on the other side of that. That is about the only caveat concern that I have at the moment for anybody. People that are immunocompromised should be getting vaccines because we know that this virus can burn inside you without you even knowing for a long period of time. And that's actually one of the origins of the UK variant. It's thought that it actually was never cleared out of people that were immunocompromised, and it gave the opportunity for it to mutate and work out ways to escape our immune system. So my only reservations from the data that we have at the moment is we really should be looking at people that have a high level of allergic reaction. So not a bee sting when you were 4 years old, or one reaction to one thing when you were 20. It's like, no matter where you turn, you're allergic to things. You should find a space where you can get vaccinated and know that you have care there if you are that 1 in 100,000. So at this stage, there seems to be no no contraindications, no reasons why you shouldn't get it. And really, in our workplaces, we should be striving to it. I was saying this to a number of places. If we can get 80% or more of the people in our workplaces vaccinated, masks come off. Okay, the mask mandates disappear. And we will see that through the CDC. We will see that happening in the next couple of weeks, that will come. So we might need to still wear them in the community because we won't be 80% out there. But if we can get our workplaces to at least 80% vaccination, we are getting to that stage where we can interact the way that we had been in years past because of the immunity, the protection that is provided from this vaccination. So, I mean, I am in a hurry to get there. I am so done with all these, controls in workplaces. We can do it. We've got 95% of the population vaccinated against measles. We know that we can do this. It's just that there are people that are going to be resistant or, on the fence. And we just really need to be not forcing them to do it. It shouldn't be a mandate. It should be little bits of information. We should be countering the scary news stuff of 1 in 100,000 with look at what this has done. And that's what we need to do. It's just slow. This is the first part of it. Slow education, see the benefit of what's going on, and then bring more people into the fold with the knowledge that we have.
Thanks.
Doctor, what do you say to those who are skeptical of the healthcare industry generally, and as a result might be disinclined to get vaccinated?
Yeah, so unfortunately, there's a history, not just in the US, but throughout the world of people in underrepresented populations being their health not cared for as well as other people. And that is, serious concern. And there's a lot of skepticism that goes with that, are they really doing this in my best interest? One of the things that people may not know with the recruitment of the Moderna and the Pfizer vaccine, a lot of epidemiologists and immunologists started smashing their fists on the table and saying, stop recruiting the middle-age, Caucasian population to this, because everyone was putting their hand up because they're more trusting in science. And so when it got to about 60% of the recruitment, they realized that the people that they were bringing into the fold, into the trial, were not representative of the general diversity in our population in regards to, origins, race, history or genetics and those type of things. So what they did was stopped and said, we are going to target, people in those communities. So we had done really well with getting Caucasian Americans, Asian Americans, but really terribly at getting, Latino, getting people of color into those. And so they stopped, and then they started pulling those populations in there. And we see that in both of them, 20 to 30% now of the people incorporated into those trials were people from minority communities. And that's exactly what we want, because that's representative of what we actually have in the United States. And so what they've done is then they take that data and they break it down and look at racial data in regards to adverse reactions. We look at it in regards to effectiveness, and they saw that there was literally no difference between it. So they have been well represented in the studies, very well represented in the studies. The data is very strong to show that it provides protection to everyone equally. But we also know that people have this natural hesitancy towards medical treatment when they have had these biases in the past. And so we need to be mindful of that. It really takes not somebody like me standing up and saying, it's great for you to get it. It gets people, when they're looking at things, a mirror. So somebody that is a person of color saying, I had my vaccine, it worked well, I feel great. It needs to come from that, and it needs to happen over time. And so when people of within your own community start getting it, I would be celebrating that from the top of the rafters, that they're the ones, when people see mirrors, rather than looking in and seeing other people doing it, but mirrors like themselves, that's when people start going, this is a reason why I'm going to get vaccinated, is because, Erin doesn't look like me, but they do, and they did it, and they had a good experience. That's what we need to see more of. So there's nothing that I can do and say to Latino or people of color or anything like that to make this easier for them. It has to come from within their own communities, and it needs to be fostered from there. I am trying to do that and help with that through the mayor's office for the advancement of immigrants in Boston. We've actually had 3 meetings about this and making connections for people so that they can share resources and stories, because that will have more of an impact than anything I can do and say. It comes from stories, and it comes from, experience within their community.
Well, Dr. Bromage, on behalf of everybody on the screen, I know we're all so grateful to you for doing this for our courts and for everybody involved in our courts. We really, really appreciate it. So thank you so much.
You are most welcome.
Thank you,
And
Doctor.
thank you for letting me be part of this and our journey forward.